And okay, and so this week, we're going to talk about task abstraction. And if you remember, in the last week, we talked about, say, to design a good validation, there are two things. And first, you have to make sure the validation fits with the type of data you use, which we'll go through different types again before we start a new one. And the other very important criteria is you have to make sure the validation meets the specific task and the needs of specific task. And so that's what this lecture is about. And so yeah, as we said, and we're going to go through what we covered in the last week quickly. And so last week, we start with explaining what is data validation, makes it, say, unique and different from other way to analyze data. And so the first thing is, it's augmenting human capabilities rather than replacing. So it's try to work with human rather than replacing human completely, and in the analysis of decision making. And then, so the second unique thing about validation is it's replaced cognition with perception, in the sense we show the data visually so you can see them, which is perception, rather than have to think about in your mind, and which is the excuse me, yeah, and rather than have to think about the problems, and which is the cognition. Okay, and then we talk about why we choose visual visual presented visually rather than, say, using sound or smell or touch, and because the human vision system has much higher bandwidth and compared to other channels, and also we can the human brain can processing visual information much faster. Okay, yeah, this comes back to what is a good validation, and we definitely talk about it's not about how fancy or colorful or even how beautiful the validation is. It's really, say, does it meet the characteristics of the data set, or does it meet the requirements for the tasks? Those are only two criteria. So essentially, we're only measuring how effective a validation is, and this depends on how well it meets the characteristics of the data set and how well it meets the needs of the tasks. That's the only thing we need to care about. Okay, and then finally, we have this discussion on in terms of limitations. So there's only so much validation can't do. Obviously, it can't solve all the problems, but also in terms of how big the data set is, it can visualize. There's also limitations. So there's three of these. And first is the limitation from the computer. Excuse me, yeah. The first is the limitation of computer in terms of how much data a computer can store and processing. And the second one from the display in terms of how many data points a display can show. Usually that's limited by its resolution. And finally, the limitation comes from humans. And even you can show lots of data on the screen, we as humans might not be able to comprehend or make sense of it. There's not much point. And just by purely showing more data, it does not really make it faster or better data analysis. It turns out that the human part is the most limiting part. We can only see a few hundred items sensibly at the same time, and maybe 1,000 will be pushing it. But anything beyond that, say tens of thousands, is definitely beyond our usual capabilities. Okay, and then so the second part of the last lecture is talk about data types. And as we mentioned, and the only criteria to say if the data validation is good or not depends on whether it meets the characteristics of data set and whether it meets the task. So you need to understand different types of data and you choose the right method. That's why we need to understand different types. And so we have many different, three different types essentially. And the first one is called data types. And the second one is data set types. And finally, we have attribute types. A bit confusing, but hopefully we'll get more used to these ideas soon. And in terms of data types, you have the items and the attributes. And these, if you think of spreadsheet, and each row is item and each column is an attribute. So each row can be, say, a product in a supermarket, and the columns can be the name of a product, its price, and its weight, etc. So these are attributes. And columns and items made of the data set type called table. And then we have the links, which are the connections between the items. So that's here. So you have the items and links, which give you the network, which is the second dataset type. And then we have positions. So these are the longitude, latitude, or XY coordinates of the data points. And that together with the item and they give you geometry. So you have the items and you have the position of the items, and then you have geometry, which essentially is a map. And also there's grid and the clusters, and with these ones we didn't really cover. And there's grid and fields we didn't really cover because we're not using them. So I'm mostly concerned of the field of computer graphics, which we will not cover, which was beyond the scope of this module. Okay, and then also among the different data types, and we also talk about for attributes, you have subtypes of attributes. And because attributes is actually one of the things we're going to use the most. So the attributes can be the name of the product, the age of a person, the address of a person, etc., etc. And you have different tabs, and you have the categorical and ordered. So basically, categorical means you don't have an order. For example, you have different type of shapes, and there's no particular order saying, and circle is before or after a cross. And only you can say is circle is different from a cross. That's categorical. And sometimes it's also called nominal data. And the other type is called ordered. That means you have certain orders among the values of attributes. One called ordinal, and in the sense you have different dress sizes in which you have natural order. You can from small to large or large to small, but you can't do any computation on these sizes. You can't say I have a small size and multiple by medium size, which does not give you any meaningful size. And then we have the last one, and which is the quantitative. Essentially, these are numbers. So any numbers will go under the quantitative part. And this is probably the ones you're most familiar with. For the quantitative ones, you can certainly have orders because they have small, medium, large. But also you can do computations. You can say 1 + 2 or 1 × 2 or 1 to the power of something. And so that's a quantitative. Yeah, it's always a bit confusing when we first start with all these different types. But hopefully, and as we go through, you'll get more and more familiar with these different terms. Okay, and so in this lecture, we're going to cover two things. And the first one is about the analysis framework. And so we kind of touched on this already. It says, and how do you design a good evaluation? So the only measurement of a good evaluation is how effective it is, and it based on two things. One is the data type, and the other one analysis task. Those are the only three components of the analysis framework. So it's quite easy. I mean, we'll go through again as well anyway. And next part is about task abstraction. As we said, a good evaluation have to meet the requirements of the task, and what are the tasks and how do we meet their requirements? So that's what the task abstraction part is. Okay, and we'll start with the yes, okay. I should do that. I'll do the attendance code now. Give me a second. Let me get the attendance code. Actually, faster if I do it online. Attendance. Okay, I just typed in the attendance code in the chat, so you should be able to see it now. No? Okay. Now let's get back to the slides. Oh, one black. And okay, and so this so-called analysis framework has three components: the what, why, and how. So the what is actually the data types, and the why is the tasks, and the how is how do you visualize it. So if you know the tasks and the data types, and how do you design the visualization? But we'll talk about these in more details very soon. First is say, and why do we need kind of framework? So can't we just go about design visualization once we have the data and the task? And in theory, you can, and this framework is kind of give you a guideline and to make sure you properly check all the different design possibilities. And so in other words, give you kind of a structure and to make sure and you properly explore the design space. And if you remember, we talk about design space, and which just basically means all the possible design options. And we said there are many, many design options, depends on which chart you choose and which attributes you choose to visualize. And how do you visualize the attribute? Do you show it as a X coordinates or show it as color or sizes? So the entire combination of these is very big. And so practically speaking, it's not possible to try all of them, because this could be hundreds of thousands or even more. And so what you want to do is you want to make sure you explore the entire design space. And let's say this is your entire space, and this is your first consideration when you first started, and you don't want to be too focused on specific type of design. You want to be open-minded, consider all different possibilities, and gradually narrow down to the most effective ones, or at least one you think. So what we want to avoid is you start with a very narrow-minded design. So, okay, for example, I have to use this type of chart, for example, and then you try to refine that chart. You can make it a little bit better, but you potentially did not consider many other possible solutions. So that's something we want to avoid. And when you do this, this type of approach, and we first started, there might be too many choices. And then the method is try to say, how can you narrow these down quite quickly? Because the way to narrow down is not to test every single possible ones, but say follow certain guidelines. You can exclude many options quite quickly without actually have to test each of them. Okay, anyway, so there are two main ideas. And the one is to make sure you consider as many options as possible at the very beginning. And then you try to refine or improve it gradually. So that's the first iteration, second, third, maybe the last one, before you settle on the final one. So at the beginning, you want to be open-minded, consider different options. And the other way is how do you narrow down quite quickly to find the one you want. Okay, and as we said, and the what is about the data part. As we said, you need to understand the types of data, the characteristics of data, for example, and how many data you have. And then these are very important in terms of validation you're going to design. So if it's, say, And if it's a categorical data or it's quantitative data, it has impact on your visual design. Or if you only have 10 items or you have 10 million items, and will again affect your visual design. Okay, and so the why part is essentially the task, and we shall talk more in the second half of this lecture. And it's really about you need to understand what the validation is for, what the user try to find from the validation, and you make sure to meet that particular requirement. Okay, and then finally, is the how part, and this is where the idioms comes in, which idioms, as explained the last time, is almost like a guideline. It says, okay, if in this kind of, for this kind of problems, for this kind of task, and this might be a good way to design. And this is a way to help you to quickly narrow down the different options. But also, these are not strict rules. You don't have to follow them sometimes. And for example, there is no idiom for specific task and data combination. Or maybe for specific needs, it no longer works, certain tasks and in sense and circumstances, certain idioms does not always work. Okay, and so just to show you again, we already seen this picture before. This is about the data, and which is essentially the what part. So we'll talk about different data types and data set types and attributes. And you can imagine, so for each different data set types, we'll have different set of visualization methods. So for tables, we have visualization specifically designed for tabular data. And for networks, it has its own visualization methods, because you can imagine, and say any methods designed for table would not fit for networks because it's unique structure. And similarly for geometry, it has its own set of visualization methods. And for this module, we're going to mostly focus on the tabular data visualization. And because this is the most common one, you will came across a lot, and the most often in actual say analysis of your future job. Okay, and this is the part we're going to cover today in terms, so that's the why. So this is considering the different tasks or the type of task people would need to use the analysis for. And also we kind of break down the tasks into different levels. And we're going to explain more in later, for example, and analyze is probably the high level one, and search is the middle level, and the query is the lowest level. Okay, and then finally, there's how. As we said, these are kind of like the idioms, and it's for different type of data and task, how to do them. And we're going to cover them when we talk about different type of data. We'll kind of group this different how idioms based on the type of data. Okay, and so that's a brief discussion of this analysis framework. And so it's actually very important. You should keep that in mind. And that gives you kind of the bigger overall kind of structure of how you're thinking or how the module would work. And because we're going to talk about different specific visualization methods, and then later on we're going to introduce more, say, the analysis part as well. But overall, it's still the same, and it doesn't matter what you need to design or create, even creating, say, a machine learning workflow, and it has no validation in it. And you still have to think about, okay, what is the type of data you have? And also you have to think about, okay, what the analysis you need to support, or what kind of results you need, and then to design the analysis processes. Okay, and so we're going to talk about tasks now. Again, we'll start with some, how do I say, kind of background. And so it says why we want to analyze tasks abstractly. And so as we said before, we need to consider about the task you want to support in the validation. Okay, but for this analysis framework or this what, why, and how framework, and it encourages you to consider tasks in more abstract form, and rather than say a domain specific way. And so you have say you have a spreadsheet, and you might come from say a supermarket, or if came from a university student database. Okay, and if you just sync them in a domain-specific ways, there are too many possibilities, and it's not possible to have design guidelines or idioms for every single of them. So syncing things abstractly would allow us to have come up with more practical guidelines or limited numbers you can actually use, because even one is from the supermarket and the other one from university, there's still many similarities in terms and the data set in terms of the type of analysis you need to do. Okay, so once you abstract, which would reduce, excuse me, would reduce the number of possible tasks, and you can allows you to reason about the similarity and differences between tasks. And obviously, for example, you want to find the, let's say you want to find the distribution of the price within the supermarket, or you want to find distribution of the student age within the university student record database. So those are two, kind of looks like two different problems, but if you take out of the context of the specific domain, and they are both looking at the distribution of a quantitative attribute. One is price, the other one is the student age. So in that sense, it's not that different. You could potentially using the same type of validation for those, because they'll look at same type of data and same type of analysis. And in some cases, you would see, okay, and it's actually still quite different. For example, one is looking at quantitative data, the other one is looking at, let's say, a network data. And even in the same context, you know, they are quite different tasks. Yeah. So if we don't do abstraction, then every task can be potentially different. And for example, even in the context of supermarket, one supermarket might have a slightly different data format than the others. And then even in that case, then there's kind of task from analysis tasks from two different data supermarkets can look different. Okay. So what we want to do is we want to kind of remove certain superficial things, and which does not have too much bearing on the actual visual design, and look at the part which are actually more relevant to the visual design. For example, the different type of data, which we already talked about before. And here we will look at different type of analysis. Okay, and then if you remember, okay, let me go back a few slides. So now we're gonna go back to here. So if you remember, we have two parts. The left-hand side is called actions. The right-hand side is called targets. And I'm gonna start with the action part now. Okay. So first you need to understand you have three levels. And so it's first called analyze, search, and query. Okay. And the first thing you need to remember is, so the terms like actions, analyze, or search, they have very specific meanings defined in this framework. So this is like a part of the analysis framework with the what, why, and how. And they are not, the meaning, the way they use are not like as a common English word. And so for example, and in some cases, they are very similar. And for example, discover and is usually how you would use discover in daily English. But say, for example, the word lookup, it has very specific meanings in the context of search, the way they define it in this framework. So that's something you need to be careful. So later on, for example, when you do your coursework, I would ask you to analyze the task you need to do, use this kind of framework. You have to use the words in the specific meanings they are defined in this framework, not in the sense, in the common English words in that sense. Okay. Okay, and back to the actual framework itself. Okay, first says it has 3 levels in the sense. So the analyze is the top level one, and within analyze, you have different type of search, and then within each search, you have different type of query. Okay, so these are not like a 3 orthogonal or independent aspect of the actions or the part of the task. And this is most top level one. Okay, maybe easier when we actually go to the specific examples. Okay, so we kind of, yeah. I think it's better, these are better explained later on. We went into the examples of each different part of specifically. Okay, so first we have the analyze part, and it has 2 parts. One is called consume, and the other one is produce. And so the difference would be the consume will be the type of analysis which you actually look at the data that's already there. Okay, and it's not about consuming the validation, but really the data that is there. Whereas produce, you're actually creating some new data. And so it could be annotate, which adds something, or could be something as simple as you calculate some, say, average or minimal maximum values from the data set. Has also additional new data from the data set. That's what produce is about. Okay, and we look at consume first, and this is most common one. So this discover, which is, and so you need to find something from the data set, which is probably, again, the most common ones among consume. And usually doing data analysis is you need to find something from the data set. And so we did this lab exercise, you have to find something interesting from the car data set. And sometimes the task is more specific than that. So for example, let's say I have a $10,000 budget. What is the best car I can buy for $10,000? That's a much more specific task. But still, and this is a type of discover task. And the second task will be present. And so this is like the part, okay? You already analyzed your the car data set, and you have a list of findings, and you need to prepare a PowerPoint slide and to show me and the rest of the lab. And that's what the present is. Okay, so in the present part, you already know what you found. And then your job is to pass that information to others, but also convince others as well. And because other people haven't done the analysis, they don't know how you come to the conclusions. And you need to explain to them so what you did and how you come to the conclusion, and make them sure, and so they can understand this is actually correct. So that's similar. Let's say when you present your results in the lab exercise, I would ask you to say, including the data, the actual validation as well, so I can know the conclusion is actually correct and you did the right analysis. Okay, and so the final example is called enjoy. That's a less common one, in the sense the people using data visualizations and they want to understand data, but that's not for business purpose, and it's like a hobby or personal interest. That's the only thing, and that's what the enjoy is. Okay, so a bit more about discover, as we said. So first, consume is probably the most common one. And in terms of data, you want to find something from the data. And the discover is find something you don't know before. Okay, so sometimes this could be by chance. And so again, so this is kind of like two quite important type of discoveries. And the first one is something unexpected. And so you don't know that thing exists in the data, or that's a pattern in the data. And you only discovered it because you see the data and you discovered it. And so if you remember, again, from the lab exercise and in the car data set, the example I showed of visual analysis, we can show there's almost a linear relationship between the dealer cost and the cost of the cars. So that is something probably you didn't know before, and you only see that when you start to plotting the price in the validation. You can see that very clear relationship. And the other type of discovery is something you would know or you would have guessed, and you can use validations to confirm. For example, okay, let's still use the car data set example. You probably would have guessed, say, and if you have a sports car, it's probably more expensive than, say, a normal car like a sedan. And then that's something you can plot in your validation, and then to see, you can plot the price of, and you can show the price of the sports cars and the other cars, then see if actually the sports car is more expensive, which turned out probably the case. And I would say, and in many cases, you probably need some kind of theory or hypothesis or hunches before you starting to create a validation. And the first one, the unexpected one, is also very important as well. And sometimes this is probably more valuable because you gain something surprising and unexpected. Okay, and then so the first one, and actually usually allows you to generate a new hypothesis because of something unexpected. And whereas the second one, and it's more like you verify hypothesis. For example, I think a sports car is probably more expensive than other type of cars. And then you can use the validation to confirm that, whereas you can see the price of cars, a sports car is actually higher, or maybe sometimes lower, and either confirm, or either verify or disconfirm. Okay, and yeah, and the second part is about presentation. And so again, as I mentioned before, it's in terms of what you want to do here is very different, and you want to present the result of your discovery to other people. So this is usually done after the discovery is done. So you would prepare your slides after you've done the analysis on the car data set. Okay, and so it's about telling the conclusions, and sometimes it's a bit more, it's more than just a single picture and a sentence saying what the discovery is, and you can tell this even as a story to explain something a bit more complex. Whereas, say, so far, an example is mostly just one picture, bullet point of a sentence or two, and that's not usually a story. You can have a few slides to cover something more complex. And for telling stories, and you need to guide users through the connections. And so almost like doing a writing, but doing a writing using pictures. Okay, and so this will be quite common, and especially involved in any more complex or real-world decision making. And there's people specialized in different type of analysis, and finally they all have to report, and the manager or the boss have to make a decision, and by combining all the information together. Okay, and one of the common way of doing this is called infographics. And it's something like this, and it's usually static, but doesn't have to. It's just say presenting you all the informations about a particular project, a particular topic or problems. And this is a generic one, which will not really tell you something, but you probably see some of these examples before, which essentially and give you the information about a particular topic. Okay, and then there's the okay, and the next one is called enjoy. As I said, and so this is a bit different and compared to the first two, the discover and present, which are almost like the two parts of the same process. So usually you do discover first and then to present the results. Enjoy would probably include potentially including both, and just usually for completely different purposes, because these are someone not doing data validation and presentation as part of their job, and just so as a personal interest, they are interested in doing this. For example, it's not necessarily say they have any hypothesis they need to say confirm or disconfirm, or they don't need to generate a new hypothesis, for example. And this is usually just because of curiosity. An example would be if you look at some information, so you look at some, say, magazines or online website, and just a hobby, on a topic, a part of the hobby, and it may have some validations there, and you are interested in, you just maybe spend more time look at the validations. So this is enjoy. It's not really say you're doing any analysis or want to confirm any hypothesis. Okay, and so I'm going to show you something like this. It's called name Voyager. And so what it shows is just showing the popularity of the name over time. And so it was published on certain website. And so if I click here, should go to the website. Yeah. Okay. So okay. Okay, let me maybe use this example first. And so what you can do, and you can type in a name here, and the validation will show you how popular that name is over the time. So, and when the baby is born, was the baby given this name, or how many baby was given this name? So what happened here is says, and I typed just one letter O, and so that's showing all the names which start with letter O. And here, obviously, they have different names which start with O. For example, here, Oscar, I'm not sure if you can see, and it's quite popular in the 1890s. Lots of people, baby born at that time is using the name Oscar. And here, and the blue color means that's for baby boy, and the red color means for baby girl. And obviously you can see the names start with O becomes much less popular in the 1960s. And the reason we don't know, but something obviously, and that is a trend. Again, the popularity picked up later in the 2010s. So the data here, the pictures here, stopped at 2012. So if I look at this, and so this is actually now is all the names over all the times, how popular they are. As you see, if I mouse over, you can actually see what that name is, because, okay. So this is the name William, and it's very popular in the 1880s. So you can see the rank in the 1880s is #2. So that's the second most popular name back then. And this shows how that changes over time. And obviously now, okay, and still quite popular, but not as popular as before in terms of the number of babies have. And you can choose and boys or girls name by selecting them. Okay. Okay, so you can see, okay, John is actually the most popular boy's name in the 1880s, and that rank reduced, or the percentage wise, and it probably is still popular. It just say you had more names or more different names as the time goes on. And also, you can type in a specific name. So I'm just typing in my name. Okay, so it's actually Chinese name, but it's also okay. And so you can see, so these are all the names which start with KAI. So it's not just the Kai, but also like say Kathleen, or different spelling of Kathleen, or this is also Kathleen. This is Kaylee, I assume. But actually, if it's Kai, and it's usually just blue, and therefore just limited to boys, you can say, okay, and that's how popular the Kai is. It's ranked the number 299 most popular name is in 2013. Are getting a bit more popular over the years. And this name Caden, Cairo, etc., etc. Okay. Okay, and just back to the slides. Oops. And the whole point is, and people look at this validation, try to do some analysis, or even share the results with their colleagues or their friends, but really they are not doing this for the purpose of doing any analysis. They want to confirm any hypothesis. They just find that interesting. That's all. That's the main point of, say, being enjoyed. Okay, so that covers the consume part. In the sense, you don't generate any new data in your validation. You just present the data visually, and you try to analyze or present the results. Okay, and then we come to the next part, which is produce. And this part, you actually creating some new data, and you don't actually made up data. For example, and you have this car database, and you just manually adding a new models and some data about that particular new models. No, not like that. The produce any all of this is based on what is already in the data. Okay. And then this is usually just used to help you help the analysis processes. So we're going to talk about each of these and in more details in the next few slides. Okay, so it starts from here. So the first one is annotate, and just basically that just means, and you might take a note of something discovered in the validation, in the analysis process that might be useful. So this is actually not just applied to visual analysis. And if you do any analysis and even do your homework, you might find something interesting. You want to make a note just so you don't forget. And you can come back to this later, remind yourself. So this is not like the new raw data you created. It's just something about the data you want to write it down, annotate. And you can also do annotations on the validation. So for example, here, you write a note, say, Turkey is losing money. Okay, that's something you discovered, you write it down, and you can add that to your validation, which becomes, so this does not comes with the original data. So in the original data, this information does not exist. That's something new that you created. That's why it's called produce. And it's an annotation like a note. Okay, and also you can potentially record. For example, this one. And if you want to use this in your report, like a PowerPoint presentation slides, you might capture the validation state together with the annotation. and that screenshot itself, screen capture itself, becomes a record. Okay, and so it can be screenshots, could be the bookmarks or your annotations. Okay, and then you can even record a analysis process. So in that sense, say instead of just recording one screenshot for finding, you might record and all the steps before that, how you reach this conclusion. And that can be also quite useful later on, either for your own review or for presentation, because then you can show other people how you reach that conclusion. At least just if you look at this one, and it's not very clear to say why. You can see Turkey is losing money, and you can see Turkey here. It has pie chart, shows some colors. You don't really know what color means here either. So you might want to, and you need a bit more information at least for the people look at the visualization to understand how you can see that Turkey is losing money. Okay. I assume saying the record and annotation is quite obvious, and in terms of their differences, and record is capture something, and it will be either a state of validation or say like almost like a movie type of recording. So either do a screen capture or the screen cap. Yeah, both screen captures. One is a screenshot, the other one is over a period of time. Okay, and in the sense that record is also produced because either the screenshot or the video recording or the screen capture video is new. That's not part of the original data, and in that sense, it's produced. And annotate, as I said, it just notes. You add some new information, usually for yourself. Sometimes it's, and for other people potentially as well. Okay, and so later on, and you can actually do. Actually, you have this record function in almost all software. It's just not necessarily visualized. So, and in any software that allows you to say undo, and it needs this kind of record function so that it can remember what you have done before, so they can undo the option. So for example, in the Microsoft Word processor, then you can go back to previous or maybe 2 steps ago. And because underlying or in the backend, there's this record function, which actually records each steps you did, so it can undo, or maybe even redo. Whereas in visualization, you can capture each different visual states. Okay, and actually it's possible to do that in Tableau, but that's not a, how do I say, public, like more like experimental feature. It's not public available in the, say, the released version. And similarly, you can do Annotate and in many other software as well. And again, if we use Microsoft Word as an example, you can say add the comments to a certain part of the text, and that's Annotate. And it's here, the only difference is you add a note to a visualization, to a picture, not to some text. That's the only difference. That's record. Okay, and the last part is the derive. And so it's produce new data based on the existing data. And sounds quite abstract. It's kind of quite important. And because we're going to come back to what that is. I think it will become much clearer once we see the example. And first, I just want to say, it's quite an important part of the design process. So because an important part of the design process is design what data to use and how to use it. You can, for example, you have the car data set, you have many attributes, and then first thing you need to decide is which attributes to use and which not to. It's probably not make too much sense to include every single attribute in the data set, because for specific validations or specific analysis questions, and only the relevant, you probably only need to include the relevant ones, and you have to decide what are the relevant ones. And sometimes you have to transform the data because, and for example, it's just simply because, and the format is not the way that you can use for validation, but sometimes is the answers you want to find is not best shown in the current way the data is presented. And so you create newly derived attributes from the original ones, or you transform. So in terms of derived ones, something could be doing, for example, and you have a water temperature attribute in your data set, and you can transfer this into hot, warm, or cold. And this might varies. What means hot depends on different person or different conditions. And for example, and the water temperature is 10 degrees, and it might be cold in summer, but hot in winter. Again, so these, then you have to decide what to do. Okay, and the other one will be, say, the city names, London or Paris or Berlin. And then these are useful, but then you use that can derive the actual X and Y or longitude, the latitude of these cities. These are derived attributes. Okay, and you can also sometimes do this and maybe give you something more interesting. And so this is like the original data, and it tells the import and export and of a country. But for example, and if you much more interested is the trade balance of the country. So whether the country is importing more or exporting more. So what you're really interested in is the difference between these two. So if you take export minus the import, which will be the net export or trade balance here, so if that's the thing you're actually really interested in, so you might be able to plot the difference between the two rather than show these two lines separately. Okay, so that's about the first part, which is the analyze. We said this is the top level one, so almost you always start analyze something, and then to either involves consume and produce. And so these two are not exclusive. And you might look at the raw data, and you might create some new data. It's not exclusive. It says if I consume and then can't produce, not like that. And then now we go to the second level. And this is the part, as we said, these have hierarchies. So it doesn't matter whether you consume or produce, you probably would involve different type of searches. Okay, as we said before, and the search here is close, but not exactly as search as we use as double, as like an English word. And it's very specifically searching for patterns in the data. And this is the middle level ones. Okay, and then they have 4 different type of searches. And based on whether you know and where the target or what you're looking for is in the validation, and then depends on also whether you know the target or not. So essentially, do you know the things you're looking for? And so if it's, you know the position of the target, and also you know the target, and there's a particular term, give it, and called a lookup. And then if you don't know the location, and you know what you're looking for, and that's called locate. As I said, again, these ones are not used as English words. They have very specific meanings based on the target and the location properties. And similarly, for anything that you don't know the target, if you know the location, it will be called browse. And if you don't know the location, it's called explore. I'm going to see some examples later. Okay. And so first we're going to do the lookup. So if you can see, here is the lookup. Okay, and the examples I gave you there is to say find vice chancellor in the university organization chart. And but also I mean, for example, this is another example would be say find the person in the phone directory. I think that's much less common example now. People don't really use phone or phone directory anymore. But you used to have these books and which list all the people and their phone numbers. And if you want to use that phone book, usually you know the person looking for. Otherwise, you will not go there if you don't even know the person's name. Okay, so in that case, you know the target. And also in those cases, the location of the person you roughly know. And because the phone book is always ordered by people's name, for example, either first name or last name alphabetically. So for example, if the name starts with A, you know it's at the beginning of the phone book. If it starts with Z, you know it's at the end of the phone book. So the location is also roughly known. And that's the lookup means. Okay, so in this case, and we need to find the vice chancellor in the university organization chart. So this is the organization chart. It could be university, it could be company. And so the vice chancellor is like the boss as the most senior person in the university. Okay. So in this case, you know who you're looking for. I'm looking for vice chancellor, and you will see a box which says vice chancellor. And also you roughly know the locations. You know the vice chancellor should be the top middle of the chart. It's not going to be somewhere here or here at the bottom or in the corners, either this person or these persons. So you roughly know the location and the target. So that becomes lookup. Okay, and this next one would be locate. And so you know who are you looking for, but you don't know the particular location. And for example, if you need to find someone by name, so if you want to find me and in this organization chart, and so it's deliberately so you can't read the text, but you don't, okay, you know I'm probably not in the top. I should be somewhere in these ones. But there's no way you know which kind of these branches I'll be in. You have to go through them one by one to find me. So in that sense, you know what you're looking for. You're looking for me, but you don't know where I would be in the visualization. Okay, next one would be target unknown and location known. So you don't know exactly who you're looking for, but you know roughly where it is in the validation. And so, for example, you want to find the program director of the computer science department. And you don't know who this person is, you know it existed. And you, for example, you know roughly, okay, this is the computer science department. And then the program the head of department, or let's say the program director, would probably be this person here. Will be top of the branch. So you know the location, but you don't know who the person is. Okay, and the last one is called explore, in the sense you don't know the target or the location. Yeah. So, for example, you want to find the person with the most connections in the chart. And so say this person, it has two connections, one connects to there, the other one connects to there. These actually more than two connect to all these people. And so if you need to find the person with the most connections, you have more or less check everything in the chart, maybe potentially this person. So it connected to all these ones, probably the most, or maybe this person, and it connects to many other people as well. So you don't know which person it is, and you don't know where to be, could be anywhere in the validation, and that becomes explore. And okay, so that covers the search part. And then finally, we come to the query. As we said again, so the query is like the lowest level within the 3 layers, the analyze, search. And that means for each analyze, you have a different type of search. And then for each search, it will be one of these things. So it could be identify, compare, or summarize. And so identify is to find usually a single target or a few. And compare, you have to look at more than one target. And summarize, so it's not about the specific target. It's say kind of multiple targets, and it's not about how do I say a difference between them. The general, let's say, the summarize is about the common things of the multiple targets, and compare is about the difference between the multiple targets. Identify is usually a single target. Okay, and so I'm using example here. We have a visualization, and it shows the US election results of different states. And so this is not the most recent one. This is one from, I think, 2016 or even earlier. Okay, but the important thing is you have these different states of America. They're colored either red or blue. And so the red one means the states voted for Republican, and the blue one means the states voted for Democratic. So these are two main parties in the US. Okay. And then, so in terms of identify is if you want to find out the results for a specific state. And so for this one says, I think it says Colorado, and it's blues, and it's voted for Democratic. And this one, sorry, it's quite small, probably can't see unless I have very good knowledge about the American geography. And this says, I think it says Arizona, and it's red, and that's voted for Republic. So that's you're looking at the results for individual targets, and that's the identify. Okay, and compare means okay, you can compare and different state as results for. Okay, for example, we can say okay here, and this one is red and that one is blue, so that's the difference. Or these two, they are the same, they're both red. Okay, and then summarization will be a bit more different. So here, if you want to do summarize, if you want to describe the overall kind of distribution of the states all over America, you might say, okay, and the West Coast is most democratic. So this is the ocean, and most of these and West Coast states are voted blue. And let's say the middle ones are mostly red. And then this is the northeast part are mostly blue again. So this is summarized. And you look at, say, you look like at individual ones, you look at multiple ones, and you see what's the common about them. Okay, so that covered the action part. We said it has analyze, search, and query. And so that's the top level, middle, and bottom. So for each type of a search, so each type of analyze, you have search, one of the 4 different type of searches. And for one of each of the searches, it can be either of these. And for example, for the lookup, it can be either identify, compare, or summarize. Depends on what you're looking for. Okay, I know these are many, many terms. And again, it will be a bit difficult and to kind of get your head over these and in one lecture. Again, so we're going to try to get familiar to these over the times and through exercise. And okay, so now we're gonna go to this half. We're gonna go a little bit faster. So this half talks about the target, or say, what are you looking for? And so are you looking for individuals or larger things? So for example, identify is about individual targets, and summarize is about a group of things, not just individual ones. And also again, say for example, and when you compare, what are you comparing for? Okay, so first, you can look at when you look at the entire data level. So this is not about individual things in the data set. Okay, so you can actually look at either trends, outliers, or features. Okay, so trends is probably easiest. If you have a line chart, you can see whether the line is going up or going down, or going up and down all the time. So that's trend. Okay, and then outliers, even though the results of outliers, for example, if you look at this and you can find outliers, that's probably the outliers. But you still need to have to look at the entire data set. And this point become outlier only because all the other points are at the bottom. So that makes it outlier. If you only look at this point by itself, you will not be able to tell whether this is outlier or not. So that's why this is also belongs to all data. You have to look at all data to understand it. Okay, and the features, and basically just means if it's not trend or outlier, you can just put it in the features. Yeah. Okay, again, so you need to use these. I mean, later on in the coursework, you need to be specified, and whether a user is trying to identify trends or the analysis task is ask you to find trends, outliers, or features from the data set. Again, you have to use these terms, especially features, in the way it's defined. It is not actually a common English word. So trends and outliers, the way they use are very close to how they are used in daily English. But features here is a bit different. So feature in, say, as an English word is very general and abstract, can mean many different things, but here it's very specific, means some data patterns which involves all the data. Okay, and then the next one is about attributes. And if you remember, so this is about, say, the items and the attributes of the data. And for specific attributes, you can look at single attributes, and you can look at the distribution of one attribute. Or you can look at the extreme values. What are the minimum and maximum values? And so I think you did this a lot already in the car example. And you might look at distribution of the, say, the fuel economy of, say, sedans, or you look at, okay, which car has the highest or lowest city MPGs. So these are look at one particular attributes. And you can also look at multiple attributes. So again, I think you tried this many times already. And so the more common ones you would try will be the correlation and similarity. So correlation, you try to show the relationship between two attributes. Probably the most common one is say, okay, as say, I can't remember now, and maybe say the horsepower of the car increases, and then also the price. So usually the higher the horsepower and the more expensive the car is. So that's showing the correlation between the, or you say, okay, as the weight increases of the car increases, and then the fuel economy drops, the city MPG becomes lower. So you have a negative correlation. That's quite common. Okay, and there's also, and these data specific ones. So the data and attributes one apply to all data types, but for network, you can look at, say, how different things are connected, or say how many connections a data point has. So these are unique to network data. And then for spatial data, you might look at the shapes or the areas in the data. Again, these are things unique to this particular data set type. Okay, I'm gonna, just because we're running out of time, I'm gonna skip this part now, and so we can talk a little bit about the Tableau in the other lecture slides. And so this is a kind of summary of what we covered. Today, we talked about why, and essentially it's about the task that you need to support in the validation. And so that depends on the action you do, and then the type of things you want to find from the data set. In terms of action you need to do, they have 3 levels. The high level ones, you either say analyzing all the existing data, and you may produce additional, say, nodes or recording or new attributes even with produce. And these two are not exclusive. And then for each type of analysis, let's say it's a discover, it will involve searches. Actually, say for one discover, it might involve multiple type of searches, and each one needs to be designed differently. And then search depends on whether you know the location or whether you know the target. You have these 4 different types. And as we said before, for one type of analyze, you might have multiple searches. And then for each of these searches, and it will be either look up, say, individual items, comparing, or do a summarization. And this side we just came through in terms of different type of things you look at, and at the entire dataset level or at the attribute, one or multiple attributes level. And we have some specific different targets or patterns, let's say, and you can have for, say, network or spatial data. These are unique ones. And okay, and just before we finish this part, I want to emphasize again, later on, when you need to identify the actions or targets from a data analysis task or the validation you need to design for, you need to use these terms not as English words, but as a specific terms defined in the context of this why framework. So an explore means a search, not knowing target and not knowing location. That's a very specific means what explore means. Not explore in a common English word. If you use English explore as a common word, then you're probably not going to get any mark for that part of the coursework. Okay, and so this is, so in terms of reading, so this is chapter 3 of the textbook. Talk about why and task abstraction. Okay, and then we still have a little bit of time. So what I want to do is I want to show you the, let me move this one up, and a few other slides about the Tableau validation part. If I can find it now. And we probably don't have time to finish all this, but later during the lab, we're going to go through more about how to using Tableau. Okay, and last time in the lecture, we talked briefly about the start page of Tableau and what the main visualization beauty interface means. And today we're going to using whatever we can cover in 10 minutes to do a little bit more. Okay, and Tableau have this panel called the Show Me, which many of you find or tend to use them at the very beginning. And what you can do is if you select some attributes, if you remember, the dimensions are the say non-quantitative, the categorical attributes, and the measures are the quantitative ones. And if you select some attributes, for example, I select order date, which is time, to recognize, if you see this link, it recognizes time, and sales, which recognizes a number, the hashtag means. And then the Tableau would recommend some visualization for you just based on the data types. These are the common ones. So these are the line chart we recommend. This one is grayed out. So that means you can still possibly do that. but it does not recommend. So this is actually based on the idioms we're going to cover in more details later, based on the type of data attributes, and maybe even amount of the attributes you can choose a right chart type. And maybe, let me see. I'm just waiting for it to start. Okay, I probably just, because of time, I'm not going to show you in the actual Tableau now. I just stay with the, where's my mouse? Oops. And just show you the different type of validations you can potentially do. And the first one is very simple, and it's called cross tab, or just essentially a tab validation. But for example, we can link different data together, or maybe show different colors of the text. And you can do map, so you can show colored based on certain values. Actually, this is not the best one, where you can represent each area with a pie chart, and this way you can actually show 3 different values. Okay, and you can do more complex tables, and for example, you can color the background of the cell to indicate something, or you can put a square or rectangle there, use the size and color to indicate something. And this is something called tree map. People find interesting, but really, it's best used to represent a tree structure. And if you don't have a tree structure, you probably shouldn't use a key map. Oops. Okay. And this is a bar chart, and you should all be familiar with bar chart. Maybe this one is slightly more complex. It's called a stacked bar chart. And so you have not just 1, but 3 bars, and each bar is broken up into 3 sections. And you can do line charts, or this is a field line chart. So you have areas below that which are filled with color, and pie chart of these ones. Okay, and these would sing again. So this is just a scatter plot, and so you have 2 dimensions, and each point, and then you can change, say in this case, and the color and shape of the point to represent some information. Okay, this is called a circle view. It's more or less showing the distribution of the different values, but instead of, say, showing as, I mean, it's just showing as a point, really. For example, for order priority, you have critical, high, medium, and low. And for old orders, which high priority, and this shows the profit. And there's someone with it says this point here with very high profitability or high profit. And these are the middle ones at the main range, you can see, and the colors shows the type of the furniture, or the type of the products, or this furniture, office supply, or technology. And you can break this up. For example, break this up and as the category first, then you see within each category how the order profitability is for different order priority categories. Okay, and so you can have multiple other types, and we're going to maybe talk about these later on, and bullet chart, packed bubbles, and somehow this is also very popular, but usually it's not the most, say, effective way. For example, if I need to compare, say, the size of these 2 circles and this green one here and this blue one here, it's just not that easy to see which one is larger than the other. And you can have a histogram, which we'll explain later. And this is the Gantt chart. And you can add trend lines, or sometimes almost like the regression lines. So this is linear regression. So this is something extra you add to the data set and will be under the produce. And it's possible to do. And in Tableau, and you can see, and also Tableau would calculate many of these common statistics as well. And you just need to describe the trend model. And they will show you, okay, what exactly did you use in terms of linear regression and all these different statistics and the summer squared error or mean squared error, etc., etc. Tells you how good the regression line is. Okay, and this show you how to add trend lines and reference lines, and which you can see, or maybe you can cover that in the lab. And also, quite importantly, you can do sorting. This is useful if you want to find the minimum and maximum values. And you can use this to sort, for example, all the bar in a chart by certain values. Okay, so we'll stop there now, and we'll cover more details in these in the lab today, and to cover more details exactly how to use Tableau. And in terms of what's covered here, it's chapter 3 of the other book called Tableau Your Data. That's, I think, is also available as an online copy. Okay, and I think that's it for today.